Let me introduce you to the tractor here that we're going to be working on. This is an oldie but goodie classic. It's a Case 580 CK, and it's gone through extensive restoration work in the past 5 years, from down deep in final drive transmission work, rebuilt brakes, new bearings for all 4 wheels, injectors, injector pump, all new electrical wiring, front axle spindles, etc. But we put off working on the hydraulic ram cylinders. Some of them are leaking hydraulic fluid pretty bad, but now we've got another problem with the backhoe swing, and so we'll show you what's going on with that. Now, of course, the backhoe swing is what makes that swing over from side to side. But the weird thing going on here is that the operator is not touching any controls to move the backhoe swing. He's just lifting the tractor up from side to side to show how it's just flopping around on its own. Look at, even this old guy can push it and pull it back like opening a door. It's supposed to stay locked in the last position it was in. The hydraulic system as a whole works fine, but something is really wrong with this backhoe swing. Watch him, no hands. It's just flopping over on its own, and it has weak or no response to his commands. So, the official book directs you to look at the control valves down under here, but we'd rather not have that be the problem, because it's a nightmare of bunch of hydraulic lines that are packed together so they're hard to remove with a wrench. Swiss watch precision and white glove cleanliness requirements. And you can see there's the swing valve. And of course, with Murphy's Law, it's the more complicated one with all these extra little parts.
It's the nightmare repair job from hell.
Now, I had my own suspicions. It seemed like something could be wrong down in these 2 swing cylinders. And they leaked anyway, so why not take them apart and see what we could see. Uh-oh, here comes the magic cat. I know it's going to put some spell on me.
Bolt going home, Shazam.
Okay, take it out again. Now, the swing cylinders are unlike anything else on the tractor. There's 2 of them, and they work together in tandem. They're Siamese together hydraulically. But unlike other twin cylinders working together like on the loader, these are opposite each other. When one's pushing, the other's pulling. And I'm guessing that's why the control valve for the swing is more complicated than the others. And the way they mount on this tractor, they swivel from side to side from the middle on what they call trunnion pivots. And that's the female socket up there, and down here is a flange with the axle trunnion sticking up through the frame into that socket. There are 2 pivots for each cylinder. This is the lower one, and there's the lower one for the other cylinder. We'll be talking more about these later. Now's the time to break this cylinder gland nut loose, because it's being held firm in the tractor. And that's a gland wrench, and it has pins on the ends that match these holes. And you can see this one's been boogered up a bit from past use, or should I say abuse. Well, we've come to find out later that somebody had tightened these down extra tight because they thought that would help it stop leaking. You also got to check and see that the set screw, if there's any, get it out of there first. Look all around on it and make sure there's no screw in there. The factory tightening spec on this, I think, is around 200 foot-pounds, but this one is not moving. But after some heavy-handed chisel beating, I finally got this to come loose. Whoa, something is wrong. This is unscrewing way too easy. There should be stiff resistance from the piston seals. Oh my God. Backhoe won't swing, huh? Now this has 2 piston halves, and that's only half, so the other half is still in there, along with a very big hardened bolt. that was supposed to be torqued down to 700 foot-pounds, keeping both piston halves firmly tight on the end of the rod. How in the world did that bolt come loose? Well, anyway, the bolt's still in there behind this piston half. We got to get it out without scraping up the cylinder walls any worse than they probably already are. Now, if the seals are still intact on this piston half, it's going to be hard to drag out of there. And we don't want to be scratching up the surface. So we want to try and pull this thing straight out. I was just starting to make some special tool to go in here when my neighbor Tom came up with this great idea, an old pair of pliers. It's just got to have a good ridge there at the jaw, like most pliers do. And it'll fit inside of that piston. Then take a hook from a come-along or winch, put them in the plier jaws, and the more you pull on it, the tighter it grabs the hook. Pretty cool. Now this is a reenactment because I didn't get it on film, and you can see the pistons kind of laying in there cockeyed. But the idea is it comes out to a come-along, then a chain over to a tree, or the bumper of a car, or whatever, and then drag this straight out. And the tractor was parked so that that tree would be straight out ahead of these swing cylinders in case we needed to do something like this. Well, it all turned out to be a bit overkill. We probably just could have grabbed the cable there with the hook and yanked on it because the piston seals were all boogered up and weren't making any resistance. But it was good to be cautious with dragging out this piston because it could have scratched up the sides of the cylinder walls, and we don't need any more of that. So, what other goodies are in there? That looks like it used to be a round washer that got smashed. Ah, there's the big bolt with the 700 foot-pounds of torque that it didn't get. Some sort of pin. That bolt's hollow. And a spring. Oh, this is stuff unique to swing cylinders that other cylinders don't have. Oh, that used to be together, and I bet it used to be straight. Yeah, these parts, they go into a little relief valve in the back, so when you swing the backhoe all the way to the left or right, it doesn't crash real sudden. It's a gradual stop. Now here's an undamaged bolt pin setup, and when the backhoe swings all the way to one side, that pin pokes into that hole in the back of the cylinder and activates this relief valve and makes the backhoe swing come to a more cushioned gradual stop. Those threads look boogered up. And down inside there's boogered up too. I'm gonna have to get a tap and thread those clean again. That is, if we're gonna try and rebuild this cylinder. The swing cylinder has already been removed, but I'll explain the procedure how it came out. You can see the sockets open in the frame where the trunnion pivots used to come through. Here's the upper one, and here's the lower one, and here's what I'm going to call the trunnion shaft flange. And when installed, it goes up into here all the way, more than that, and it goes up into the cylinder socket like this one over here on the other cylinder. Notice that clean worn spot there on the frame. That's from the weight of the cylinder swiveling back and forth for many years, and it's ground down in there. Now if these flanges are too difficult to just pop right out, and they might be, the manufacturer has left a nifty way to get these out. See, these are the 4 holes that normally mount this flange onto the frame and the bolts pass through. But these 2 holes are different. They're usually not used, but they're threaded, and you can screw 2 of the 4 bolts into these. The idea being that they come through, and as you tighten each one of them, it forces this flange up out of its socket so you can get a pry bar or whatever underneath and pull it out the rest of the way. So like this, I've used the 2 screws to raise this up. Then I can get a pry bar under there, get it up out of the socket. Now it's loose, but it's got to get around that hydraulic hose, and it squeaks out. Here's that swing cylinder now assembled and laying on the ground with its trunnion pivot system. And I need to spend some time talking about this because these trunnion pivots are really worn out. Something's got to be done about it, whether we get a new cylinder or not. This part fits in there, and you can see there's a bushing that's pressed in there that can be replaced. See how loose it is? Here's what it looks like up in there. That's way wrong. It's not supposed to do that at all. It's only supposed to swing from side to side. And then look up there at the top at that gap. That means this has been ground down into the bottom so bad, and the bottom of the socket's worn out so bad that you've got that bad gap up there. And that bottom trunnion has dug in so deep here that it's grinding into the cylinder wall itself. Now the cylinder wall is only half as thick as it's supposed to be right there.
Ouch.
And the whole thing's way too loose. I wonder if the maintenance guys forgot that there was a grease fitting right there. Well, so that bushing can be replaced. The trunnion shaft flange is worn down too, and I don't know what I'm going to do about that. Maybe build it back up with welding and turn it back down to its original factory size on a lathe. I don't know. So we got to figure out what we're going to do here. So here's my options as best as I can figure. Used, well, that could be a good way out and cheaper, and I could swap parts from the two of them and make one good one maybe. Because with used, it's hard to know the condition inside. How about rebuilt or new? Well, they're getting hard to find for this model. Oh, I see plenty for sale for newer models of the 580, but I don't know if they fit this, if things have changed. And those prices have a bit of sticker shock with them. I'd like to go cheaper if I could. So what about repairing the one I've got? Well, I think I'm going to proceed ahead on with that route and see how far I can get. With luck, it might be the cheapest way of all. Or at least more fun for us GearHead machinist types. So I want to dig into this thing slow and easy. Let's start out with something simple here. This swing cylinder rod end's grease fitting keeps getting its top munched off every time the backhoe swung from one side to the other, so I want to take a look at what's making it do that. And we got to get this off. For some reason it's tight on the end there. I wonder if that has something to do with why the bolt didn't stay tight. Let's see if we can clean up the threads that are boogered up in here. I sent off and got a tap that fit. It's about half price of the other ones. It's an import, but it seems like it's pretty good quality. It's 1 1/4" by 12 fine thread, and it's a taper tap, not a bottom tap. A taper tap's thread cutters come on real gradual from nothing to full threads over a long span, so it's easy to get this started. Well, easier. And you could see if I went in, I'd be in big trouble because they're not lined up. The red lines get closer together at one end and further at the other. You've got to look at this tap from two different directions to see that line, like looking down from the top and then looking across from the side. And I want to really take my time here and make sure I'm going in straight. I do not want to carve new threads. I want to try and find the original thread path and just clean up the mess. So it's good to take the time. See, those lines are more parallel, equal space, so I think I've got it lined up and I'm ready to go in further. Put a little oil in there and take her on in. Now, if I didn't have this find the original thread path and it was cross-threading, this would get very hard to turn after maybe half an inch or so, and then impossible to turn. But if I didn't have a good setup to hold this rig, I could put this tap, which has a square end, into a good vise and screw the rod onto it this way, and so I could put a bar up here and easily thread this down onto the tap. For the bolt that screws into those threads, it's got a bit of minor damage, mostly at the very beginning. Now, I've already done this, but I'm just going to show how. This is a triangle file, and you just follow along the threads pushing down, but you push to the side also against the thread that's boogered up and less on the thread next to it that's good. And you don't want to have this tilted as you're going in there. You want to try and keep it flat and just work at it until you get the thread track halfway decent again. The very beginning threads have to be clean and gradually start out from nothing. Now see, there was another spot there that was a little boogered up, not too bad, and I did the same thing there with the file. Looking pretty good. Let's try it out. All right, don't force it. Find the track or file some more until it finally screws in like it should. So here's the piston halves, and besides the damage they've sustained, there's other evidence here that tells me about their past, such as these various rust marks on here. I think it's from condensation or water in the hydraulic fluid, which this tractor was guilty of, emulsified gooey. And when the tractor is parked for long periods of time and the fluid isn't all the way to the top, the rust happens at the top. So this cylinder shows at least 2 past cylinder rebuilds, because the piston top was randomly by chance never in the same place after each rebuild. My guess is that this first one was when the tractor was new, then this was another time, and this was another time. Maybe. But anyway, the rust isn't in a critical area, so it can just be lightly sanded off. Now, as far as the damage to these from when the bolt came out, that's what these are here. That broken pin and things crashing into this. And I'll just take the high points off of them. It's not going to hurt anything where they are. But there's one immediate problem about the damage when this bolt came out. It passes through this piston half just fine, no problem. But this piston half, I can't get the bolt through. So what's going on there? Oh, well, there's damage inside this circle that's sticking in and won't let the bolt pass. There's some more. Got to get those ground out of there. And this bent washer, I think this caused it. After the bolt came loose, this got jammed in there. See, that's where it originally was supposed to go, but it got smashed into there, and that's likely what boogered up the threads on the end of the rod too. So we got to clean those up. I've got my trusty little Dremel tool with a metal cutting disc, and I'm just going to take these parts that are sticking out into the circle away. It doesn't have to be a precision fit or anything. It just has to be big enough to let the bolt get through. That's a little high ridge on the end, and it's kind of hard to see, but it's real sharp and it's sticking into the circle. There you go. Okay. All right, that fits in good now. On these piston halves, we just want to clean off the high points of the dings and dents. Don't have anything sticking out. I can run a little bit of fine sandpaper over that afterwards, smooth it out. Next, I want to remove these trunnion bushings for replacement, and they are pressed in there, so you can shrink them down with an arc welding bead or torch An arc welding bead would be better because you could go across it quicker with less risk of collateral damage, but I don't have one right now, so I'm using this. I want to avoid having the flame deflect down and heat up the cylinder, so I've got a slug of steel plate down in there. I've made some homemade pry bars, but I need a little fulcrum point down in there. By the way, this does have to cool down before I could proceed with this next step. Now I can get underneath the edges of the bearing and pry on that plate I put in there. These are just old distributor wrenches that had box ends. I cut them off. After each lift I have to put another chunk of metal down in there. Okay, that's far enough. I think I can get it out the rest of the way with just a wrench. Now here's something curious. Out of the 4 trunnion bearings on 2 swing cylinders, this one measures out near brand new, where the other 3 are totally worn. So that's about 5 thousandths over brand new, and this way, which is the way it wears the most, is about 12 thousandths over brand new. So this one's been replaced, and not that many operating hours ago. And there's clear evidence here showing how they extracted the bushing. Somebody used some kind of a screwdriver chisel down in there to pry it out, but first they heated this up hot. You can see the black marks, and there's one on the other side to match, and then they pried it out while the outside part was swollen up from the heat. Now this swing cylinder that fell apart inside did suffer some scratchy damage on the cylinder bore, but surprisingly little for what happened in there. There's 2 dings and 1 scratch about 4 inches long, and parts of them are sticking out proud, and they're going to scratch the brand new seal kit that I put in unless I get rid of the high spots. So I am going to hone this cylinder out, but all I really care about is taking down the high spots. Notice how I'm not clamping this down very tight because it's a flat jaw and it's a round cylinder, and if I clamp it down too tight, that might permanently bend and distort the cylinder into an oval. A no-no. The cardboard allows even more gentle handling. Just a little tighter. The hone I'm going to use is a rigid type, and I suppose any type would work, but a rigid type with long stones forces a damaged cylinder back towards an even diameter and a true circle. Now this job isn't a cylinder in a car engine where you want a crosshatch scratch. You want it to be pretty smooth when you're done. A rigid hone won't tolerate an out of round cylinder, so that's another reason for not clamping the cylinder and the vise too hard. So here's what I've got for the stones. There's a 180 coarse grit, a 280 finer, that's what's on there now, kind of medium, and then a really fine 500. The hone manufacturer suggests using, for cutting oil, 8 parts kerosene and 1 part motor oil. So here we go. They also say for this size of a bore, the speed of the drill shouldn't be over 300 RPM. This one's 1,000 RPM, so I have to kind of hold back on the trigger. Now those scratches and dings are towards the back, and I'm coming up on them now. I'm going to linger there for a while and let the stones take those high places down. So this process just continues over and over again, and then I went to the 500 stones and did it some more. Did it until I was satisfied with the finish. Now the piston seals are fairly forgiving, but we're talking no more than 6 thousandths off the diameter. And I would never want those stones to drag when I pull this out. Be real careful. So let's get a look at these stones. They might give us some clues about what went on in there. The manufacturer gives this paddle sander, and that's where the stones ran up against the high points in the barrel. And it looks like they gave the stones a hard time, but the stones won out. No more high spots. Here's a view inside the cylinder after I finished honing, and I wanted to show what's going on in there. The other two dings are gone. I can't find anything anymore. I'm kind of honed in on the main scratch. You might think, well, that's a drag, but it's not very deep. We've seen some of the other cylinders on this tractor have really bad scratches that go all up and down. But even so, the bottom line is those cylinders still worked. Maybe not as strong, but surprisingly not really noticeable. So this one little scratch here is really nothing, especially when you're on a budget and the tractor won't be used in a commercial industrial situation. I think it's going to be fine. So before I finish out with part one here, I wanted to give a little preview of some of the things that will be going on in part two.
Such as?
How are the boys going to get this swing cylinder trunnion ordeal fixed? Are they going to have to buy another cylinder? How are they going to fix those sloppy trunnions? Especially those trunnion shaft flanges. A little torching? A little welding? Building them up, taking them into the machinist to have them turned down on a lathe? Will he use his own welder? Or will he use his own lathe? And what are they going to do when they can't break these bolts loose on these other cylinders with 900 foot-pound torque bolts? Sheeeet. How are they going to clean up these boogered up holes on the other cylinder? Can they salvage and save these glands that have been rusted out? Or even explain the 3 styles of gland nuts on this tractor? Will they be able to repair the butcher job they did on that swing cylinder gland nut and successfully install a new seal kit? Well, only time will tell, but rest assured our boys will be on the job with their precision control of fluids and forces.
But will this backhoe ever swing again? Stay tuned.